Okay, today we're going to try to find the absolute extrema, or the absolute extreme value given these conditions, maximize this function on this sphere. You can tell this is a sphere because you have x squared plus y squared plus z squared equals 19. So if you divide all sides by 19, you're going to have a equal to b equal to c. So that's how you know it's a sphere. Okay, so we're going to use a method called Lagrange multipliers, which pretty much says that the gradient of f equals the gradient of g lambda. What is lambda is called a Lagrange multiplier. It's a scalar quantity. So this is very similar to an optimization problem. So the first thing you want to do in order to see if you can use this method is you have to have two functions pretty much. We can call this a function of x, y, and z, and we can call this a function of x, y, and z, right? So we can say f of x, y, z equals 2x plus 3y plus 5z. And we can call our g of x, y, z, so g of x, y, z is equivalent to our sphere squared minus 19 equals 0. So what you're maximizing, call that your f function, and what you're maximizing it on, call that your g function. Okay, so the first step we have to do is we have to find the gradient of f. As you remember, the gradient is simply just df over dxi plus df over dyj plus df over dz, if there is a z component, k. So that's what the gradient equals, and likewise the gradient of g is the same thing, but you're going to be taking the gradient of g with respect to x, y, and z. So applying, you should have already been introduced to gradients before you start using Lagrange multipliers, so you should be alright in understanding this method over here. So the gradient of f is going to be 2i plus 3j plus 5k. So this equals the gradient of f. Now the gradient of g is going to be 2xi plus 2yj plus 2zk. Now following this equation over here is that we set each component equal to each other. So this is the x component when you put in parametric form, and this is the x component here. So we set these two equal to each other, set these two equal to each other, and set these two equal to each other. So we say 2 equals 2x, 3 equals 2y, and 5 equals, let's be 2z. And finally we place a lambda, the Lagrange multiplier, next to our g, according to this equation over here. Okay, so, so these are not the only constraints. It's very important that you remember your initial constraint, the sphere constraint, where you have x squared plus y squared plus z squared equal to 19. You can't forget this last constraint, or it'll be very difficult, if not impossible, to solve this simultaneous system of equations. So now, up to this point, we have to figure out what x, y, and z are. So in order to do that, we're going to have to somehow find what lambda is. So we see that 2 equals 2x lambda, 3 equals 2y lambda, 5 equals 2z lambda, and we have these initial equations over here. So if we can solve for x, y, and z, get x by itself. If we get x by itself, we're going to get x equals 1 over lambda. So x is a function of lambda. We can get y by itself, we figure out that y is 3 over 2 lambda. And if we get z by itself, we figure out that z is equivalent to 5 over 2 lambda. So as you can see over here, we solve for x, y, and z, but you might be asking, now what? Well, if you look at the final constraint, we have x squared plus y squared plus z squared equals 19. And also, we solve for x, y, and z here. The only thing preventing us from figuring out what the actual value for x, y, and z here is lambda. So if we can plug x, y, and z into here, we can find what our lambda is. And then finally we can plug our lambda back into these x, y, and z's and figure out the actual value for the x, y, and z. So that's exactly what we're going to do. We have x equals to 1 over lambda. So we have x squared. So we have 1 over lambda squared plus y squared. So this will be 3 over 2 lambda squared plus z squared, which is 5 over 2 lambda squared equals 19. So now if we solve this equation for lambda, we can finally figure out what lambda equals. So 1 over lambda is equivalent to 1 over lambda squared. 3 over 2 lambda is 9 over 4 lambda squared. And 5 over 2 lambda squared is 25 over 4 lambda squared. And don't forget, all this is set equal to 19. So let me go ahead and make some room over here. So we have like terms for over here. We have 9 over 4y lambda plus 25 over 4y lambda. If we add those together, we're going to get 34 over 4 lambda squared. And finally we have this 1 over lambda squared. So the common denominator between these two is 4. Multiply this by 4, gives you 4. You get 38 over 4 lambda squared. And that equals 19. So now we just solve for lambda over here. So we get 19. Okay, it looks like I'm not going to be able to finish this video at the time elapsed for YouTube is running out. So I'm going to continue this on part 2. So just scroll down and you can go to part 2.